Welcome to Unit 3, Part 3, Finding Solutions. In this presentation, we will talk about ways to prevent climate change and ways that we can become more resilient to the impacts of climate change. Let's get started. Responses to climate change generally fall into two categories: mitigation and adaptation. Mitigation involves reducing the amount of greenhouse gases entering the atmosphere and sequestering carbon dioxide by building or restoring carbon sinks. You'll hear the term carbon sequestration as we explore solutions. This is the process of capturing and storing carbon dioxide from the atmosphere. Forests and oceans sequester or capture carbon, acting as a carbon sink. However, even if we do everything we can to mitigate or prevent climate change impacts, some impacts of climate change are already happening and will continue to worsen. Adaptation is the process of adjusting to current or expected climate change and its effects. Successful adaptation helps us build climate resilience, another term that we will introduce later in this presentation. Let's take a closer look at some examples of adaptation and mitigation. Adaptation examples include preparing homes for flooding, redesigning buildings and infrastructure, and protecting forests and other ecosystems that can lessen climate change impacts. Mitigation examples include switching to renewable energy, sustainable transportation, and energy-efficient technology to reduce the amount of greenhouse gases entering the atmosphere. Some solutions to climate change fall under both mitigation and adaptation, like protecting water and energy conservation and green infrastructure. Let's take a closer look at some examples of how Hawaii is trying to mitigate climate change by reducing and sequestering our greenhouse gas emissions. Although Hawaii's overall energy consumption is low, our state uses about 11 times more energy than we produce, and we pay more for electricity than any other state. We are also the most petroleum-dependent state, with more than 4/5 of energy consumption for electricity and transportation coming from petroleum. However, Hawaii has set ambitious goals to reduce our dependence on fossil fuels, largely by shifting to producing electricity from renewable sources. Renewable energy comes from sources that are naturally replenished, like wind and solar. Hawaii was the first state to set a goal to reach 70% renewable energy by 2030 and 100% renewable energy by 2045. Part of reaching this goal involves creating large utility-scale solar and wind farms to help power our electric grid, which is where most of our electricity comes from. A power grid is a complex system that transmits power generated in facilities, like power plants, and delivers it to customers like you and I. In addition to large utility-scale projects, there are smaller distributed renewable energy sources, like rooftop solar, which directly power homes and businesses. These smaller systems can feed excess energy back to the power grid, or can be off-grid systems with batteries. Solar power provides more than half of Hawaii's total renewable electricity generation, and most of this is from small-scale solar panel systems. You'll explore more about Hawaii's progress towards these renewable energy goals in one of the activities. There are also mitigation efforts to reduce other greenhouse gas emissions. Implementing methane-reducing methods in beef production, reducing methane emissions from landfills by reducing food waste, and using composting instead of synthetic fertilizer, since fertilizer production produces nitrous oxide, another greenhouse gas. Energy efficiency measures how efficiently an appliance, building, organization, or country uses energy. As part of Hawaii's 2030 goal of reducing emissions by 70%, 30% of this reduction comes from energy efficiency. One government initiative includes changing building codes for improving insulation, requiring it to use less heating and cooling energy. Innovative technologies have also introduced vehicles requiring less fuel, or changing the way airplanes operate to reduce fuel use. There are also things you can do in your own home to be more energy efficient. Changing your light bulbs to LEDs, hanging your clothes instead of using your dryer, and washing your clothes in cold water, and turning off lights when not in use are all examples of energy efficiency. In addition to reducing our carbon emissions, another part of mitigation is finding ways to sequester CO2, which means to capture and store CO2 in order to reduce the amount in our atmosphere. As we learned before, natural carbon sinks like forests, oceans, and soil sequester carbon. Therefore, protecting and restoring natural carbon sinks like our native forests are important. Sustainable farming methods such as composting can also help store carbon in the soil. In addition to these natural sinks, scientists and engineers are also proposing new technologies to remove and store carbon from the atmosphere. With the combination of reducing emissions and sequestering CO2, Hawaii hopes to become carbon neutral or not produce more greenhouse gas emissions than natural sinks can absorb. Some organizations, such as UH campuses, also have their own goals to reach net zero by year 2035. We have learned how mitigation strategies are important in reducing atmospheric CO2, which can help prevent further climate change. But some effects of climate change are already occurring, which is why adaptation strategies are also necessary to protect people and ecosystems from these impacts. Can you think of a time in your life that you had to recover from a difficult situation or tragic event involving your family, friends, or even at school? Your ability to recover quickly from events like this is your personal resilience. The same can be said about ecosystems, communities, and infrastructures that may need to recover from various climate change impacts. Climate resilience is the ability to anticipate, prepare for, and respond to hazardous events related to climate change. So, to build climate resilience, we must develop successful adaptation strategies to help us be less affected by and recover more quickly from climate change impacts. These adaptations may include protecting biodiverse habitats like coral reefs so that they are more likely to recover from the impacts of climate change, such as coral bleaching, or restoring our native forests and watersheds to protect our freshwater supply as droughts become more common. We can also improve emergency preparedness education in the community to better respond to natural disasters caused by climate change. Adaptation and resilience planning allows us to build communities that are better adapted to thrive in the face of climate change. Part of this planning process involves assessing how vulnerable a community or ecosystem is to the current or future climate risks, and then taking steps to lessen or better cope with these risks. To look at an example of adaptation planning by local government and community groups, we will look at Hawaii's response to the threats posed by sea level rise. Sea level rise generally impacts different areas in three different ways: coastal erosion, high wave damage, inundation or flooding that may impact areas more inland. A vulnerability assessment is done to identify and prioritize communities or areas most at risk to one or more of these threats. Then a plan is created using one or more of these four different types of sea level rise adaptation strategies. Protection involves holding the line, or physically blocking higher sea levels and high wave damage using seawalls, sandbags, or other types of coastal armoring. While they may provide a relatively quick and affordable fix to the problem, they can cause coastal erosion and may not be a long-term solution. Accommodation modifies new or existing developments, like raising houses on stilts to accommodate occasional flooding from sea level rise, which can at least temporarily allow coastal residents to remain in their homes. Ecosystem-based adaptation involves the conservation and restoration of ecosystems like coastal dunes and wetlands that provide protection against storm surge or waves. Retreat involves removing or relocating existing developments, which, while costly, can be a long-term solution. Shoreline development setback rules can also help limit new development in coastal areas vulnerable to sea level rise. As you can see, selecting an effective adaptation strategy for a specific area can be difficult as each strategy has its pros and cons. Often, a combination of these strategies may be used in the same region. In one of the activities, you'll take a closer look at sea level rise adaptation planning in Hawaii. Let's go over the activities in this part. For the first activity, adaptation versus mitigation, we'll look at examples of these two strategies. The second activity, Hawaii's clean energy transformation, will investigate electricity sources on Maui and how the state is doing in reaching its goals. Adapting to sea level rise in Hawaii, we'll learn about how adaptation planning can prepare Hawaii for the expected impacts of sea level rise. In the last activity, building resilience in the Pacific, you'll learn about adaptation actions being taken in communities in the Pacific to build resilience against climate change impacts. After completing the activities, complete the Part 3 quiz.